Hello everyone, hope you guys are doing well. Today I want to do a quick introduction to blockchain technology. Hope you guys are excited, and let's jump into today's presentation. Blockchain technology. First, let's talk about what a blockchain is. Simply, blockchain is an online distribution ledger system that can store information. And ledger is just a book where transactions are recorded. And one of the most intriguing features of blockchain is the ability to create timestamped append-only log, meaning that information can only be attached and viewed but not altered. So think of blockchain as a Google document where you can share it with others and add to it, but the constraint is that nobody can change the information that is already on there. And then to get a better understanding of blockchain, let's break it down. What is this term? The term blockchain itself, it comes from how it works and the manner that it stores data. And block is where information is stored, and it holds three characteristics. Number one, data, which is just another word for information. Two, hash, which is the fingerprint of the block, and it's used to identify each block from another, the differentiation factor. And third is the hash of a previous block, which connects the current block to the rest of the chain. And the reason why we need to add more blocks is since each block has a limit on how much information it holds. So for example, Bitcoin has a limit of around 1500 transactions per block. So after the 1500 transactions have been stored, then it requires another one to be chained onto the previous one. And inside the Bitcoin, the block holds a list of transactions. And for Ethereum, the block contains smart contracts. And for other cryptocurrencies and projects, it holds different types of information. In order to continue growing on the network, mining is essential to create these new blocks. And this brings us to talking about the hash. And hash is the fingerprint of some digital data, and it's used for authentication. It will look like a bunch of numbers, but know that each character holds information. And regardless of the length of the information, you will get a hash of the same size. So if we look at the picture on the right, let's say I put an input of the word fox. It will give us an output after the hash function runs to that exact same size of the hash. And the same size is also repeated no matter how many characters we put the size, like how many length of the characters that we add onto or do not add onto. In the second box, we see that it's not just, we're not using the word fox, we're writing a whole sentence down. But despite that, tool to get a better grasp of how this technology works. And this is the fundamental thing that allows blockchain and any cryptocurrencies so secure. In SHA-256, it stands for Secure Hashing Algorithm, and 256 is the bits. So, data. This is information. We're going to write hello. Did you guys catch that every time I added a new character, the hash was changing? And as I explained before, the hash size is still same no matter how many words I write or how many characters, how much information I write. And now onto the block. Don't worry too much about this. Nonsense, it's just another number. And this is the number that you can kind of set to try to find the hash that starts with, in this case, would be 4 zeros. So you see how in the background it's green? This is the criteria for this hash function. It requires 4 zeros. It will make a little more sense once we go into the blockchain. So for example, if I write H, the hash function changes and we no longer have 4 zeros. So we're going to click on the process of mining, and it took us 36,498 tries to get the hash function that kind of fills the criteria of validating this block. Okay, now onto the blockchain. So again, the nonce is the amount of tries it takes. Data is information. Hash is the identity of this block. And if we change the data input, let's say for example, hi, you saw that this hash function changed. So as this one and the third one as well. We're going to be using 3 blocks. Because I changed the value of the first one, the rest of the blockchain is going to be disrupted. So what I have to do is I have to validate this new block. So right now while I'm mining, it's figuring out a hash to figure out, in this case, 5 zeros. And it took us 56,931 tries. And again, since blocks are linked together, we have to mine for the next one to find the 4 zeros. It took us 98,000 tries on this one, and the same on here. That only took us 6,770 tries. All right. What miners are essentially doing is guessing and checking. Calculating hash takes time and computing power, and as the computer looks for more zeros to validate the block, the more time and computing power it requires. And since the blockchain is disrupted and democratized, every player can see things that has happened in the past and resisting any modifications in the past. The hashing function makes sure that people are putting in work to participate in the blockchain and incentivizes miners who grow the chain. Whoever finds the hash receives a mining reward, and this is how new Bitcoins are created. They add the hash onto the last block, and the prior block refers to the last one. So whatever gets recorded in the blockchain, it's written down forever in history, which is great for transactions. And now let's talk about some characteristics of blockchain. Number 1, decentralized. Decentralized means that there is no governing authority or a single person that oversees the framework. Instead, a group of nodes maintains the network, making it decentralized. This eliminates the risk of corruption as each node holds importance. And each node holds a copy of the digital ledger, and to add a transaction, each node needs to check its validity. If the majority thinks it's valid, then it's added onto the ledger. Continuing from the last point, number 2, the ledger system is only possible through the uses of the system, which distributes computational power amongst the computer to ensure the best outcome. However, if a person or group takes more than half of all the computing power or validation authority, they can block new transactions from being confirmed as well as change the ordering of new transactions. But however, this is not common, especially in big projects such as Bitcoin, because it requires so much computing power as well as resources to capture more than 51%. And third, the consensus mechanism. Blockchain is built upon the consensus algorithm and allows network to be built upon decision-making processes of the group of nodes. And consensus can be viewed kind of as a voting system where the majority wins. This consensus mechanism allows the network to be trustless as long as the players trust the algorithms that run the core of it. And now, what can blockchains do? This is the big question. First, eliminate fees and eliminate inefficiencies from third parties. When making an international money transfer, the verification process takes around 3 to 5 days, and the third party also takes a cut for the service it provides. So for example, let's say I am in America and I'm trying to transfer money over to China, let's say. My $10 is going to be held by a third party agent, and it's going to be checked. It's going to be processed, and this process takes around 3 to 5 days. And not only does this take quite a long time, they also take a percentage for the service it provides. Blockchain can eliminate not only the trusted party, but also the fees associated while increasing efficiency and speed. Number 2, distinguish between original and fake. Think about the supply chain, which links the creation and distribution of goods. The number of invoices and payments involving countless entities can potentially extend over to months and maybe even years. And blockchain can be used to grant access to the same information, reducing communication or transfer data errors, document production updates to a single ledger, enable faster, cost-efficient delivery of products, and even enhance product traceability. So this would be great for consumers because you're going to be able to track where your package is being sent, where in the shipping processes that it's currently in, and the increase of efficiency and data will give you a higher satisfaction. Number 3, transparency. Think about transparency that is not really seen in the modern world. For example, let's say where your tax dollars are going. Wouldn't it be incredible that with blockchain implementation, you were able to check where your tax dollars were being spent? I think that would be remarkable and a huge advancement to building a great society with greater participation. And another use case would be in medicine, where everybody can see where the medicine is and see a batch of immutable records of the drug's origin, ingredients, as well as the clinical trials. Blockchain has the potential of helping the disadvantaged as it empowers the individuals to store information. For example, pretend you're a farmer and your whole farm got flooded, and the flood forced you to evacuate, and when you came back, the copy of your deeds, it just disappeared. If you had blockchain, then you were able to put your identification and kind of store it up on this database. So you don't need a physical copy, and blockchain prevents natural disasters or things that are not within your control by containing information and making it secure. For blockchain infrastructure to be embedded into society, it requires a significant amount of expertise, time, resources, and just a variety of constant applications that has to be scalable, safe, as well as reliable. And although we're still quite in the beginning stages, I believe that the benefits of blockchain technology provides an essential benefit to civilization as we move forward. And because it empowers people instead of rewarding just a few who gets to determine how society develops. And with that stated, I want to end with a quote from Satoshi Nakamoto. We can win a major battle in the arms race and gain a new territory of freedom for several years. And we're back. I hope you guys enjoyed this small, short introductory video talking about blockchain technology. Personally, I am very enthralled and excited to see and be a part of this emerging technology and being more interested about the potential use cases. And whether you like it or not, I think if it does get adopted and see some practical utility inside society, it's so important to learn about and be aware of. And with that stated, I hope you guys have a wonderful rest of your day, and I'll talk to you guys very soon. All right? Peace.